This is Chemistry, Apologia, Module 11, practice problems. These are on page 417. All right. Module 11. Let me zoom in a little bit. Number 1, a balloon is filled with hydrogen at a temperature of 22 degrees Celsius and a pressure of 812 millimeters of mercury. If the balloon's original volume was 1.25 liters, what will its new volume be at a higher altitude where the pressure is only 625 millimeters of mercury? Assume the temperature stays the same. So here's our balloon. It goes up and there's less pressure. So this is situation 1 and situation 2. Volume 1, they told us the original volume is 1.25 liters. Volume 2, our question says, what will its new volume be? So that is what we are looking for. How many liters is volume 2? Our original temperature was 22 degrees Celsius, and it said temperature stays the same, so T2 is also 22. Our original pressure was 812 millimeters of mercury, and pressure 2 at the higher altitude was 625 millimeters of mercury. Since our pressures are the same, we actually don't need to convert them. They're going to end up canceling out. But we will use this equation, P1V1 over T1 equals P2V2 over T2. This is the combined gas equation. So now all we'll do is plug in numbers. So we know P1, 812 millimeters of mercury. Well, you know what? Before I do this, before we plug in, I'm going to go ahead and solve. You can do it either way and put the numbers in first and then solve for T or for U2, but I'm going to go ahead and solve for it now. So I'm looking for V2. I want to get V2 alone. So I have to do the opposite of whatever's going on here. Right now, V2 is times P2 and divided by T2. I'm going to get rid of this T2 first. Since T2 is dividing, I need to multiply by T2. And whatever you do to one side, you have to do to the other. So now those T2s over here will cancel out. We'll be left with P2V2 equals P1V1 T2 over T1. Now, we're still trying to get V2 alone, because that's what we're looking for. It's times P2, so I have to do the opposite, which is divide by P2. And over here, I need to divide by P2, which is the same as 1 over P2. So I'm going to be left with V2 equals P1V1 T2 over P2 T1. Now, I know that T2 and T1 are the same, so they're going to cancel out, but I am going to go ahead and plug them in just so you can see. So I'm going to move up here. I've got V2 equals P1, which is 812 millimeters of mercury. You need to write your units down every time because we're going to be canceling them out just like variables. Times V1, which is 1.25 liters, times T2, which is 22.0 Celsius, all over P2, which is 625 millimeters of mercury. Oops. Times T1, which is 22.0 degrees Celsius. And now I can cancel out this 22 degrees. I can cancel out my unit, millimeters of mercury, not the numbers, just those units. On this one, I canceled out the number and the unit because they're both the same. But here, I can just cancel out units. And what I'm left with for units is liters, which makes sense because it's a volume. So now we're going to do 812. You can type this into your calculator. 812 times 1.25 equals, divided by 625 equals, and the number we will get is 1.62 liters. We're rounding to 3 significant figures because every number here has 3 sig figs. That is the answer. Number 2. A bacterial culture isolated from sewage produced 23 milliliters of methane gas at 23 degrees Celsius and 795 torr. What would the volume of the methane be at standard temperature and pressure? STP. Standard temperature and pressure is 1 atm and temperature of 273 Kelvin. So we're going to plug all that in. So we've got a bacterial culture that produced 23.0 milliliters of methane gas. By the way, methane is carbon with 4 hydrogens. It's the simplest hydrocarbon. So 23 milliliters, it was 23 degrees Celsius, and the pressure was 795 torr. So these were my initial readings. And we want to know the volume, V2, at standard temperature and pressure. And again, standard temperature and pressure, temperature is 273 Kelvin, and pressure is 1.00 atm. Okay, these are given. So the first thing we can see here is that we have everything except for V2, so we'll be able to solve for this with our P1 V1 over T1 equals P2 V2 over T2, our combined gas law. But we also need to see that our units are not the same. We have Celsius here and Kelvin here, torr here, and atm here. So we need to convert T1 to Kelvin, and we do that by adding 273. So we will get, let's see, 296 Kelvin. And then we need to convert our pressure. We can convert this one into torr. In 1 atm, there are 760 torr. And we could have converted this one to atm. It doesn't really matter. We could do it either way as long as they're the same. And so our answer will be 760 torr. Okay, and now we're looking for V2. Now we've got Kelvin, Kelvin, torr, torr, milliliters. Our answer is going to be in milliliters. Looking for V2, and we're just going to solve for it the same way as up there. V2 equals P1 V1 T2 over P2 T1. And now we can plug in all our numbers. P1 is 795 torr. V1 is 23 milliliters. And T2 is 273 Kelvin. All over P2, which is 760 torr, and T1, which is 296 Kelvin. Okay, to plug this into your calculator, you would do 795 times 23 times 273 equals, divided by 760 equals, divided by 296 equals. And that will give us V2, which is equal to 22.2 milliliters. 3 significant figures, since everything up here has 3 sig figs. All right, number 3. A steel container with a volume that cannot change is filled with 95 atms of compressed air at 20 degrees Celsius. It sits out in the sun all day and its temperature rises to 55 degrees Celsius. What is the new pressure? It's another combined gas law problem, and now we're looking for pressure. So let's find out what P1, T1, all those are. We've got pressure 1 is 95.0 atms, and the temperature is 20.0 degrees Celsius. V1, we actually don't know. We can just call it X liters. And it sits out in the sun. The temperature rises to 55 degrees Celsius. The volume, V2, we don't know, but the volume was unchanging, so it's still X liters. What is the new pressure? It's going to be in atms. We'll just use the same formula, P1 V1 over T1. equals P2 V2 over T2. We're looking for P2, so we'll solve for that by multiplying by T2 here, multiplying by T2 here. Cancel those out. We get P2 V2 equals P1 V1 T2 over T1. Now we're still looking for P2, so we'll divide by V2, and we'll get P2 equals P1 V1 T2 all over V2 T1. Now, you can do these steps combined. I'm just doing them out so you guys can see more clearly the algebraic steps. Whenever we're working with the gas laws, we need to convert our temperatures to kelvins. So let's add 273 to each one. And we will get 293 Kelvin on this side. And let's see, 338, is that right? No, 328, I'm doing it in my head. Okay, so let's plug these in now. P1 equals 95 ATM. V1 is X liters, we don't know. T2 is 328 Kelvin. All over V2, which again is X liters. And T1, which is 293 Kelvin. Now, you can see why it doesn't matter that our volume we didn't know our volume, because it's just going to cancel out. X liters over X liters equals 1. Our unit here, Kelvin, is going to cancel out, and our unit we'll be left with is ATM. So in your calculator, you will type 95 times 328 equals, divided by 293 equals, and the answer is 106 ATM. Again, 3 sig figs, like the rest of them. And I'm going to take a break to let my phone charge. So this video will be in 2 segments.